In this case, on least square method, you've been told the power needed to drive a lathe machine as the cutting angle of the tool increases at constant speed and the depth of the cut. The relationship of the mill speed is as shown in this table. So we have the cutting angles given there and the power we have there in kilowatts. The cutting angles are in degrees. So you've been told to determine the regression of power on cutting angle. The regression of power on cutting angle. And you always know that regression of y on x is easier to deal with, isn't it? So if regression of y on x is easier, so where there is power, you say y on x. So you are looking for the regression of y on x. So it means power you let to be y, isn't it? And the cutting angle you let to be x, isn't it? Are we together? Then you come and you write the equation of the regression of y on x is the equation of a straight line. Y is equals to a plus bx. So if you go to statistics, you go to the calculator, go to mode or your shape to set up, then you select statistics. Statistics is number. So once you select statistics, you select the line you want to deal with. You want to deal with the straight line for the regression of y on x. You have that option, isn't it? Are we together? That is why it was easier to let power to be y and that, because this option is in the calculator, easier to work with, isn't it? So have you selected option of y on x, the equation of a straight line? So once you select that, the calculator will bring you a table, isn't it? It will give you a table. So after that, the calculator will give you a table with x and y values. It will tell you to feed the x value which is there. You feed the first x value, which is 50. When you press equal sign, it will take you to the next x. The next x value, which is 55. When you press equal to, it will take you to the next x value, which is 60. So you continue like that until you feed all the x value. Continue with the same procedure until you feed all x values. Continue with the same procedure and you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning you continue with the same procedure from number 1, number 2, number 3 until you reach number 9. Then you confirm those values, isn't it? Are we together? So once you fed the x values, you use the scroll buttons. There are those scroll buttons in the calculator. Use those scroll buttons to move until you get to the first y value on top here, which corresponds to 50. The one which corresponds to 50 is 62. Use the scroll button until you get back here, isn't it? Then you record the first y value is 6.2. When you press equal sign, it will tell you to record the next y value, which is 6.8. When you press equal sign, it will tell you to record the next y value, which is 7.6. You continue with the same procedure until you record the last y value, value number 9, which is 10.4. Have you recorded all the values? Where were you recording those values? See, I've said you have to confirm. You use this scroll button until you see the calculator is coinciding. This 6.2 is coinciding where 50 is, isn't it? Note that once you've recorded the last x value here, when you move there, you start recording y here going downwards. You have to scroll until you get which value of y was corresponding to 50 is where you record it, isn't it? Which y value was corresponding to 55 is where you record it. Note down there. That's why you're using these scroll buttons, isn't it? To get up there. Have we recorded everything? Record all the values? Do we have all the values? So, once you fed all the values in the calculator, you press the AC button. The AC button just minimizes the formula. You don't press an on button. The on button will reset it, isn't it? You press the AC button to minimize the screen. Then there is where by now you come, and you write the formula for the least square regression line, isn't it? So the first one, we multiply both sides by summation, isn't it? When I multiply both sides by summation, I have my y is equal to a plus bx. So I will have summation y is summation a plus summation bx. So here, I will get what? Summation y is equals to, if I sum a n times, I will get a n, isn't it? A plus n times is like a times n, isn't it? Then here, b is a common factor, is a constant, I factorize out a constant, isn't it? So it is an plus b summation of x. So that is Roman 1, isn't it? Because we are looking for xy, and here we already have y, so we multiply both sides by summation x, isn't it? So if you multiply both sides by summation x, you get summation x times y is equals to summation x times a plus summation x times bx. So there you get summation x times y will give you summation xy to be equals to what? Summation x times a. A is a constant you factor outside, isn't it? So it will be a summation x. A summation x. Remember, n is only appearing when summation has disappeared, isn't it? Where there is summation, this n is still there under summation because you are summing them still, isn't it? Then here, b is a constant you factor outside plus b, then x times x you get your summation x squared, equation 2. Because we fed the values in the calculator, so the next thing you do what? Statistics is under number 1, isn't it? So you can see when you go to the buttons, number 1 on top of number 1 is written, the key for number 1 on top of it is written start, isn't it? And it is having the color of shift. So if you press shift and number 1, it will give the options of statistics, isn't it? And what are we looking from those options? We are looking for these summations and n, isn't it? So summation is number what? Where there is written sum, isn't it? Sum is number 3. So if you press number 3, it gives you all the options for sum, isn't it? It gives you all the options for? So once you get all the options for sum, you start with the first one. The first one is summation of y. So summation of y is number? You press number 4, it gives you summation of y. When you press equal sign, it gives you the answer, which is? 75.8. 75.8. So it means when you would have summed all this, you are going to get 75.8, isn't it? Then after that, the next value you are looking for is n, isn't it? What is n? The number of these values, and n is also there under sum, isn't it? N is number? N is number? Go to statistics, AC, shift, statistics is number 1. Then you have? N is number? Go to sum. N is not there. So n is there. It is always there. See, these are the number. How many are they? First, second, third, fourth, fifth, sixth, 7, 8, 9. N is not even under regression. When you press reg is number. So if you go to number 5, so n is the total number, isn't it? And how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 values, isn't it? So n is 9. You are summing 9 values. This is the total number. When you are summing y, see there were 9 values. Yes. N is? After n, we are getting summation x. Go again. Go to shift again. And you press number 1 to give you statistic. Then you press sum. Under sum, select summation of x. What do we have? 630. After that, we are looking for summation of xy. Continue again, go to shift number 1 and go to sum. So the next one, we are looking for the summation of xy, isn't it? When you go to sum and the option for summation of xy is giving you 5,462. and 62. Then the next one is summation of x. We already have it, isn't it? Then the next one is summation of x squared. Go to the options there again and select summation of x squared. What do you get? 45? 45, 6? 45, 600. Isn't it? See, you've now found all of them. You can now substitute them to have your two simultaneous equations, isn't it? So if you substitute, summation of y is 75 point to be equals to a times n. N is 9, isn't it? Meaning that is 9, 9a. Then summation of x you found is 630. So 630 times b, it is plus 630b. So that is that your equation 1, isn't it? You move to your equation 2, summation of y you found to be 75 point. Oh, meaning this one. Oh, I'm looking for this second one. Summation of xy you found to be 54. 54, 62 to be equals to a times summation of x. Summation of x is 630. So 630 times a, 630 a, isn't it? Then it is plus summation of x squared, 45, 600. Then it is times b, isn't it? So we have 45, 600 b. Now, I want to show you the best way to do this. You don't need to go to substitution or elimination. You go to grammar. Are you seeing that? You go to grammar. So grammar here you can see we have the two matrices. This side, which matrix do we have here? The way it is, 75.8 and 54.62, isn't it? Are we together? That is the matrix we have there. Then this side, when you extract, which matrix do we have? The coefficient matrix here, isn't it? The first value here is positive 9 and this, 9 and 630, isn't it? And here we have positive 630, here is positive 45, 600. So we've extracted that coefficient matrix, isn't it? Are we together? Yes. Then the first value here is A, then B. So you extract it the way you are seeing it there. The way you are seeing it here, you can see 75, 8, 50 point, that. So can you now bring this and transform it there? We have our coefficient matrix here is 9, 630, then 630, 45, 600, then it is times AB, and it is equals to what? 75.8 and 54.62. What I've done, I've just swapped. Severe. But it has remained, meaning I've started with this to be equals to this. Isn't it? Are we together? Yes. So, this is the coefficient matrix. So, if you want the value of A, the A is the first one. Are you seeing? When you want the value of A, you just say A is equals to A, then you put D over D. Meaning A is D over D. We want to see how to get this determinant D. Are we together? That D is the determinant of this coefficient matrix. Are you getting what I'm saying? This D is the determinant of this coefficient matrix. So you put that coefficient matrix in the denominator. You see these two strokes means determinant, isn't it? And what is the matrix there? It is 9, 630, then here 630, 45, 600. Then what is B? You leave a space where you are going to write the answer. I have still not placed what is in the numerator. Okay? What is B? See, B is equals to B, isn't it? Then it is D over D, meaning D of B over D. So this matrix in the denominator is the coefficient matrix you have there, isn't it? You know, I've not found what is DA and what is DB. I'm still dealing with this coefficient matrix in the denominator, isn't it? Are we together? Which is 9, 630, 630, 45, 600, isn't it? So if you want this D of A, you substitute the column of A. A was column 1. A was column 1, isn't it? So the column 1 you replaced with the solution. What is the solution? 75.8 and 54, 54.62. Then column B remains the way it is here. Are we together? It remains the way it is here, which is 630, 45, 600. Then you come here, D of B. If you want D of B, you can see B is the second column, isn't it? So the second column is here. You substitute with the solution. Are we together? The second column is, you substitute with the solution, which is 75.8 and 54.62. Then here, the values which are here remains the way they are. Are we together? Which is 9 and 630. Meaning when you are looking for D of B, B is the second row. So we substitute the second row with what was in the solution, isn't it? When you are looking for D of A is in the first row. So we substitute the first row with what was in the solution. Is that okay? Yes. So here is now, you now get these values. If you get these values, what is A? See, the determinant is the product of the main diagonal minus the product of the other diagonal. Yes. Sendio? So you just go to the calculator and you put numerator over denominator. You press that key for fraction. Then in the numerator, you put what is the numerator? This times this minus this times this. Then you go to the denominator, you put what is in the numerator? This times this minus this times this. Then you get the answer. Have you seen what I've done? So what do you get with the answer? 1.142. Then here again, you go again to the calculator to get B. It is the numerator, you press that key for the numerator, this times this minus this times this, divide by this times this minus this times this. What do you get to be B? So you see Cramer's rule is direct, isn't it? Are we together? What do you get? 0.104. Are we together? That is what you are. So if you look very well in the calculator, there was regression of y on x in the calculator. See, there was y on x in the calculator. If there was y on x in the calculator, meaning A and B are in the calculator. So you go under regression and you check what is the value of A. Is it the same value you have here? What is the value of B? Is it the same value you have there? Shift number 1 to take you to statistics. Then you go to reg, option. Under reg, you will see A and B, isn't it? What is the answer for A? 1.1422. Is this the same thing you have here? And what is the answer for B? You see, those are the values for y on x, because this line is on the calculator. Meaning, when you now go to the line x on y, if you have x on y, it is now going to be x is equals to A plus B, by. Are you seeing that? In that case, what does this mean? This means when you are feeding these values in the calculator, if you want to get A and B, what do? The column for y, the column for x, you feed the y values. So when you want to confirm, I mean, isn't it? You see? Here, what we are saying, when you want to get the value of A, you just say A is equals to A, of course, isn't it? A is equals to A, then you put D over D. So I have D of A over D. This D is the determinant of the coefficient matrix. So it means whether you are looking for A or B, the coefficient matrix, then this one you had here, it is there in the denominator. Are we together? Whether you are looking for D of B, B is equals to B, B over D. So D is in the denominator and D is this matrix we have here. It's the determinant. Are you seeing that? And this determinant, we put these two strokes to show its determinant, which is in the denominator for both cases. Are we together? It's when you go to the numerator. So numerator, you want the determinant of A, D of A. How do we get this D of A? You go back to your equation. A was forming column 1, the first column, isn't it? So it means this first column, where the A was forming this first column, you substitute with the solution. And what is the solution? The way it is, you put it there. Are you seeing? So what is left, you just put the values which were here the way they were there. Are we together? Then if you want D of B, you can see B is forming the second column in this simultaneous equation. Are you seeing that? So it means in the second column of this DOB, the second column is where you put the solution. Are you seeing that? The second column you put the solution, then this column remains the way they were here. Are you getting it now? Yeah. Then the determinant, you know the product of main diagonal minus product of the minor diagonal, divide by this like that, and you get that, those values. Is that okay? So I don't prefer the idea of going to, after you form this your Cramer's rule like this, the idea of going to the calculator to get values of A and B is only direct when it is Y on X, because this line is in the calculator, isn't it? Are you getting what I'm saying? But when you now have X on Y, you don't forget about even switching the values first of all. When you have the X on Y, when you have the X on Y, it is still okay, yes, you just fit the X values where they are, the Y values where they are. Then what will be A? Meaning your B and A. They will be the same values, isn't it? Huh? They will not, because the values the calculator will be giving you is regression of Y on X. Are you seeing that? Will be Y on X, but this is X on Y. So the moment you have X on Y, those values of A and B in the calculator are not going to be the right values, because those ones are for this. Are you getting that? You go pamoja? So the calculator simply helps us to get these summations. Once we get these summations, we are done. Don't use those values of A and B, because those values of A and B, you can only use them when you have this. Let me make it clear like that, okay? Tuko pamoja? Very good. So that is there. Then the part B of that, you'll be told the power when the angle is 30 degrees. So before that, you found the value of A and B. So you substitute the value of A and B to get that regression of power on that, isn't it? So what is it? Roman 1. Can you now answer Roman 1? I have found A to be and B to be that. So what is Y? Y is A, which is 1.142 plus BY. B is, meaning it is plus 0.104 plus BX. So this is the regression of Y on X, where Y is power, X is the cutting angle. So you found the regression of Y on X. Are we together? You simply substitute the value of A and the value of B, which you found here with the Cramer's rule, isn't it? So you've answered the first part of that question. Having answered the first part of that question, you go to the second part, isn't it? So the first part you found Y to be equals to 1.142 plus 0.104x. So when they are telling you to get power when the angle is 30 degrees, and you know the angle, the cutting angle is x, meaning when x is 30 degrees, you get y when x is 30 degrees. So it means y will be 1.142 plus 0.04 into the value of x. What do you get to be the answer? 4.2? 4.26 is enough. And you know the power is in kilowatts. So that implies the power is 4.26 kilowatts when the cutting angle is 30 degrees. Okay? Are we together? So that is how to handle such kind of problems on regression.